Patty Simpson with Simpson Math. In this video, we're going to use the properties and rules of logarithms to condense them. So remember the rules of logarithms, that our quotient rule says that when we have two numbers dividing in the argument, that we can take the log of the numerator minus the log of the denominator. The product rule says that when I have two numbers multiplying together, that I can take the log of the first number plus the log of the second number. And our power rule says that when I have an argument that's being raised to a power, I can multiply the exponent times that logarithm times that exponent. So here we're going to use those rules to help us to condense some logs. So for instance, let's start with log base 3 of 405 minus log base 3 of 5. Now, if I were to try to evaluate this log or evaluate that log, I would see that those numbers are not pretty numbers. You know, 3 to what power gives me 5? Well, 3 to the first power gives me 3, and 3 to the second power gives me 9. So this number, log base 3 of 5, is somewhere in between 1 and 2. It's, you know, not 1, it's bigger than 1, and yet smaller than 2. So it's not a nice, pretty number. And this is true for this as well. If I go through the powers of 3, I'll find that 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243, times another 3, and we're too big. So this is 5 and a little bit. It's too big. It's bigger than 5, but not quite 6. So I can use my quotient rule, though, to condense these two. And when I condense them, I'm just going to go backwards. I have the numerator over the denominator. So because their bases are the same, I can just write that logarithm once with the base. And then in my argument, I put the first number in the numerator and the second number in the denominator. Now, as I do this division, that's equal to 81. And sure enough, log base 3 of 81, that is a power of 3. So 3 times 3 is 9, times 3 is 27, times 3 is 81. This is just a fancy way of saying 4. 3 to the fourth power equals 81. And if you look, we had 4 in some number minus, a little more than 1. And so that ended up being, or 5 in some number, 5 in some number minus a little more than 1, which gave us 4. So this is just equal to 4. And we can see that better if we use that quotient rule to help us out. Here's another example of that. Let's take log base 6 of 9 plus log base 6 of 4. Again, these are not nice, pretty powers of 6. So 6 to what power gives me 9? Well, 6 to the first power is 1, so this is a little bit more than 1. And this one is a little bit less than 1. So I have a little more than 1 plus a little bit less than 1. So I'm going to use my product rule where I have two logs with the same base that are being added. I can rewrite them with one log and in the argument multiply those two numbers together. So I have log base 6 of 36. Oh, 36 is a power of 6. 6 to the second power gives me 36. So that's just a fancy way of saying 2. So it turns out that this 1 and a little bit plus less than 1 adds up to be 2. So there's a use of the product rule to condense my logarithms. Here's another example. Take log 2 times log base 9 of 3. With our power rule, I can take that number out front that is multiplying times the log, and I can put it back on as a power. So this 2 is log base 9 of 3 squared. Well, we know 3 squared is equal to 9. So now I can evaluate that nice and simply. Log base 9 of 9, I'm just raising 9 to the first power to get that 9. We might could have seen it here as well, because 9, the square root of 9 is 3, so this is just equal to 1/2. 1/2 times 2 also gives me 1. So it's just a way to condense it to maybe see it a little easier. Now we can do the same thing with variables. Even if we don't know the numbers, we can still condense. Sometimes we want to be able to do that to solve our equations, or there are lots of reasons for us to be able to condense. So let's look at just something like this: log of x plus log of y. Notice that their bases are the same on both of those. So, and I'm adding, so I can use my product rule where I can come back to the argument. So I just write the log one time, and then in my argument, these two things are multiplying. Now it's really important here that I put the parentheses. If I don't put the parentheses here, it means something different. Like for instance, up here, if I didn't put the parentheses there, this would mean log base 6 of 9 times 4. So, you know, that's 1 and a little bit times 4. I would end up with 4, a little bit more than 4. That's a different number. So the parentheses here around that argument are really important. So I need to make sure that I put those parentheses there. There I have used my power rule to condense that. So I now just have log written one time. I don't know what x and y are, so I can't simplify that or evaluate that further. Now let's take that same idea and now just put a number out front here. So now I have two different rules I'm going to use. I have the product rule and I also have the power rule. I'm going to use the power rule first. First, I'm going to make that power come back onto the y so that this becomes an exponent on my y. So I have log base x plus log base y raised to the 9th power. Now I'm going to use that product rule to write my log one time with those two numbers in my argument. So we use the power rule first and then the product rule when I'm condensing. Let's do another example. Here we have the natural log of x minus the natural log of y. So here we're going to use our quotient rule so that we have the natural log, just writing natural log one time. Notice my base is the same. Remember, it's an understood e when I have the natural log of the numerator divided by the denominator. Let's add a little bit to that, and let's make this 2 natural log of x minus 1/2 natural log of y. Again, what I want to do when I have this power rule is I want to use the power rule first. Anytime it has a coefficient out front there, I want to go ahead and move that up as my power. So I have the natural log of x squared minus this natural log of y to the 1/2 power. Remember that 1/2 power just means the square root. So I could rewrite this as the natural log of x squared minus the natural log of the square root of y. Those two things are the same thing. Now I can use my quotient rule. That minus tells me that I'm putting this in the numerator and that in the denominator. So I have the natural log of x squared over the square root of y. So notice here again, we used that power rule first, and then we used our quotient rule. Let's put all three rules together where we're having to use all three rules. So let me give you an example. Log base 5 of x plus log base 5 of y minus log base 5 of z. First, let's just do this one and then we'll add the power rule to it. In this case, I want to do this product first so that I just have two numbers. Before I do the quotient, I want to take care of this product first. With the quotient, I just want two things subtracting. So here, I'm going to do this product first so that I have log base 5 of xy minus log base 5 of z. Now, this is going to be in my numerator while that is in my denominator. So I write it with one logarithm, log base 5 of xy in my numerator and z in my denominator. Notice that the negative exponent there, that negative logarithm, ends up in the bottom of the exponent, of my fraction, the denominator of my argument there. And we did the product rule before we did the quotient rule. So when we expanded, we did quotient, product, power, but when we condense, we're doing power rule first, then product, then quotient. Last but not least, let's just put a power rule in there so that we can see how all three of them work together. So on each one of these, I'll just throw a power, say 3 log base 5. But we're going to do the exact same thing that we did. Well, first thing we're going to do here is we're going to put the powers on each one of those first. So when we have all three of them, we're going to first do our power and then do the other two. So I'm going to rewrite that as log base 5 x squared. This, the power rule just puts that exponent back on top of there to the 1/2 power minus log base 5 of z cubed. So I use my power rule first. Then I'm going to now do this product rule just as I did before. So here I'm going to use that product rule so that I have log base 5 of x squared times the square root of y, because remember that can just be written as the square root of y. Don't forget those parentheses because it means something different otherwise. Minus that log base 5 of z cubed. Then I'm going to take and I'm going to make that equal to, use that quotient rule so that I just write my log base 5 one time with my first one in the numerator and my second one in the denominator. So there we've used all three rules. The first rule we use is that power rule, and then we used our product rule, and last but not least our quotient rule. So there we can condense the logs as well as expand them. Math made simple. Let's do some math. Thanks for watching.